In the fall of 1940, Soviet leadership made a strategic decision that would significantly change the course of Soviet fighter development, dramatically increase the flight range of all new and production fighter aircraft. The requirements were tough. From now on, single-engine planes had to cover roughly 600 miles, or precisely 1,000 kilometers in the metric system the Soviets used, at 90% of their top speed. For twin-engine escort fighters, the bar was set even higher, at least double that distance at 80% of top speed. The hardest part was that these numbers had to be achieved using only internal fuel tanks, with no external drop tanks allowed. Every aircraft design bureau received an urgent order to immediately revise the blueprints of all current projects. At the same time, one of the country's main aircraft factories was tasked with beginning production of a significantly upgraded version of the I-200 fighter, the prototype that would soon become the MiG-3, by mid-December. There were plans to bring other factories into serial production as well, but those plans had to be scrapped due to lack of time and resources. Engineers were forced to work under extremely tight deadlines. A new fuel system was urgently installed on one of the I-200 prototypes, and by late October, the aircraft was handed over for its first factory trials. To give the plane greater range, engineers placed an additional protected tank beneath the cockpit, holding about 66 gallons of aviation fuel. However, this solution shifted the aircraft's center of gravity. To restore proper balance and controllability, the heavy AM-35A engine had to be moved forward by nearly 4 inches, which required the designers to extend the engine mount. At the same time, engineers took the opportunity to address a number of serious flaws identified during earlier state evaluations of the base model. To improve the aircraft's stability in flight and prevent dangerous wing drop, they increased lateral stability by adjusting the dihedral angle of the wings. They also installed a new plate-type water cooling system whose radiator had to be moved slightly forward to make room for that same additional fuel tank. Since the fighter's overall weight had increased significantly, the old landing gear could no longer handle the load. It was replaced with larger, sturdier wheels measuring 650 by 200 millimeters. And to allow the aircraft to land and take off more safely from unpaved airfields, the landing gear fairings were redesigned, and all fuel tanks in the center wing section were lined with a self-sealing coating that would automatically plug bullet holes. The updated prototype took to the sky for the first time on October 29th, piloted by Arkady Yekatov, an experienced Soviet test pilot. Toward the end of November, the aircraft was sent south, where weather conditions allowed for full-scale joint testing with military research institutes. Meanwhile, work at the factories was in full swing. The rollout of the new modification moved so quickly that by December it was officially designated the MiG-3 and completely replaced its predecessor, the MiG-1, on the production line. By the end of the year alone, one of the key aircraft factories assembled the first 20 MiG-3s. And the approved plans for the following year, 1941, were truly ambitious. Soviet industry was expected to produce 3,500 of these fighters at the main plant, with another 100 scheduled for assembly at the aircraft factory in Kyiv. Testing of the experimental prototype was halted in early spring 1941. There was no longer any need, since by that point government evaluation teams had already put the first production MiG-3s through their paces, aircraft that had rolled off the assembly line at the end of the previous year. Military engineers had a clear objective: compare the new production aircraft to the older MiG-1s. They needed to determine whether the designers had actually managed to resolve all the previous deficiencies, how much the flight characteristics had improved, and whether the aircraft had become easier to operate. Special attention was given to pinpointing exact flight performance data, evaluating the fighter's stability, and its ability to safely recover from a spin. The aircraft's weapon systems and specialized equipment also underwent thorough inspection. The job of testing these advanced fighters fell to 2 top-tier professionals, Captain Alexander Proshakov and military engineer Andrei Kochetkov. After all the structural modifications, the aircraft's flight weight had noticeably increased, from 6,834 to 7,396 pounds. Naturally, this took a toll on its flight characteristics, and not for the better. Still, despite the extra weight, the maximum horizontal speed of the production MiG-3 at 25,590 feet still hit 398 miles per hour. That was nearly as fast as the experimental I-200 prototype, which topped out at 403 miles per hour. But there's no free lunch, and keeping that speed came at the cost of maneuverability. The rate of climb dropped noticeably. It now took the aircraft almost 2 minutes longer than before to reach 26,240 feet. Soviet pilots who tested the aircraft noted that the plane handled well in a descent, but it became less stable in a climb. When it came to spins, the new MiG-3 behaved predictably, exactly like its predecessor, the I-200. If the aircraft entered a spin, the pilot just had to wait 2 rotations, apply opposite rudder, and the plane would recover smooth and predictable. Performing aerobatic maneuvers felt just as familiar as on the older MiG-1. However, due to the heavy control forces and a certain instability during sharp maneuvers, significant G-forces built up, which wore pilots out very quickly. On the bright side, the fighter's weapon system was a genuine point of pride. The machine gun's mechanisms worked flawlessly. During testing, there wasn't a single misfire or delay caused by malfunctioning ammo feed or shell ejection mechanisms. The pneumatic reloading system and trigger mechanism proved not only easy to use but also completely reliable. The military had virtually no complaints about the bomb release system either. It performed without a hitch. Communications also saw a major upgrade. The onboard RSI-3 radio provided reliable reception at distances up to 93 miles. This was a serious step forward compared to what the old experimental I-200 prototypes could manage. But there were also serious problems. From the very first tests, it became obvious that the VI-22E propeller was a terrible fit. The blades had a pitch range of only 20 degrees, and that turned out to be dangerously insufficient. During steep dives at angles of 50 to 60 degrees, the propeller would spin up so fast that the engine over-revved way past all safe limits. This created a real risk of the engine literally tearing itself apart in midair. The factory received a strict order to immediately find a new propeller with a wider blade pitch range. Test pilots also complained about the AM-35A engine. It responded far too slowly to throttle changes, which in the middle of a dogfight could get you killed. The testers paid special attention to flight range. The MiG-3 was sent on a long-distance flight along a complex route between several airfields. The test flight covered a total of 441 miles. The aircraft flew at roughly 25,800 feet, maintaining a cruising speed of 357 miles per hour, with the engine running at 1,950 RPM. Here's the thing. During the flight, the pilots didn't use the altitude fuel corrector since the official manual for the AM-35A engine strictly prohibited using it below 26,240 feet. On February 22, 1941, after another long sortie, technicians began analyzing fuel consumption. Out of a total fuel load of about 1,020 pounds, roughly 185 pounds remained in the tanks. However, a design flaw surfaced. About 75 pounds of that fuel was trapped, unusable due to problems in the fuel delivery system. Accounting for the 110 pounds of fuel actually accessible in the forward tank, engineers calculated a real flight range of just over 500 miles. To confirm these numbers, on March 17, 1941, they decided to run a follow-up test. This time, the aircraft circled directly above the airfield at the same altitude and speed, but with RPM reduced to 1,850. The following day, the experiment was repeated on an actual route. The results were similar. Out of the initial 1,000-odd pounds of fuel, roughly 200 pounds remained, of which about 57 was once again trapped and unusable. With 141 pounds of usable fuel remaining, the maximum flight distance came to just over 530 miles. After analyzing all the data, experts concluded that flight range had dropped significantly for 2 main reasons. First, the engine consumed 10 to 15% more fuel than the manufacturers had originally promised. Second, the problem with that unusable fuel residue in the tanks played its part. In the end, the fighter's actual range fell roughly 90 to 100 miles short of what the government demanded. This was absolutely unacceptable to the military leadership, so they issued a strict requirement to the designers: bring the flight range up to that 1,000-kilometer benchmark at any cost. However, the factory engineers pushed back hard on these disappointing range figures for the MiG-3. On April 4, 1941, chief designer Artem Mikoyan, the Me in MiG, and his deputy Mikhail Gurevich sent a detailed memo to the People's Commissar of the Aviation Industry, Alexei Shakurin. In it, they pointed out that according to their engineering calculations, even with elevated fuel consumption, roughly 1.63 pounds per mile, this aircraft should still have been able to cover at least 628 miles without any issues. For comparison, during earlier joint trials with military research institutes at the Kacha Air Base, a much lower consumption rate had been recorded, just 1.35 pounds per mile. But then, during the final state tests, that figure suddenly jumped to 1.7 pounds per mile. Mikoyan and Gurevich explained this discrepancy very simply. During the flights, the military pilots had simply forgotten to use the altitude corrector, and the engines that day were burning fuel very inefficiently due to improper calibration. To prove their point, on April 19th, the factory conducted its own independent tests of 2 production MiG-3 fighters, and the results fully confirmed the designer's calculations. Before takeoff, the first aircraft was fueled with about 1,000 pounds, and after returning to base, roughly 130 pounds still remained in its tanks. This flight was conducted at nearly 24,000 feet at 357 miles per hour. The route covered roughly 680 miles, with the engine running steadily at 1,920 RPM. Excluding the climb and descent, the fighter covered about 630 miles in cruise mode. When specialists crunched all the numbers, the actual maximum flight range reached over 730 miles, and including takeoff and landing in the calculation, a full 786 miles. The second test fighter told almost the same story. At the start, its tanks held roughly 1,000 pounds of fuel, and after landing, about 190 pounds remained. The aircraft flew at just under 24,000 feet at 357 miles per hour. This time, the route stretched across roughly 600 miles, and the engine operated at 1,850 RPM. Excluding the climb and descent phases, the plane covered about 490 miles. The final calculations once again proved the engineers right. The baseline range was over 630 miles, and under real-world conditions with takeoff and landing, it could cover about 740 miles. But that magic number, 1,000 kilometers or 621 miles, became a truly fatal benchmark for both the military leadership and the entire Soviet aviation industry. This was far from an isolated case. The Soviet system routinely used political repression to assign blame for systemic failures. By order dated May 31, 1941, the head of the Air Force Scientific Research Institute, Major General of Aviation Alexander Filin, was arrested and hauled before a military tribunal. He was executed in February 1942. He wasn't the only one to suffer. The Institute's chief of staff, along with a whole string of department heads and senior engineers, were immediately stripped of their positions under the formal pretext of professional inadequacy. All of these specialists were falsely accused of sabotage and deliberately obstructing the development of advanced aviation technology. That same infamous order explicitly stated that testing of new aircraft, including the MiG-3, had been riddled with violations and deliberately dragged out. But before the purge came a tragic event. Shortly before, on March 13, 1941, during routine range tests at the Kacha base, one of the most experienced Soviet test pilots, Arkady Yekatov, was killed in a crash. The disaster occurred precisely as the pilot was trying to determine the rate of climb and maximum speed at various altitudes while simultaneously measuring fuel consumption. A subsequent thorough investigation revealed a horrifying detail. The crash was caused by the supercharger impeller in the AM-35A engine shattering mid-flight. As the fighter was actively climbing, the component shattered, sending a violent jolt through the aircraft. The unexpected impact caused the pilot to strike his head, instantly lose consciousness, and stay unconscious all the way down until impact. Engineers had flagged the critically low safety margin of this component back during the MiG-3 state trials, but the relentless pressure to meet production quotas meant such warnings were often ignored. Under normal engine operation at 2050 revolutions per minute, the safety margin was an acceptable 26%, but the moment the engine was pushed to its maximum permissible 2350 RPM, that figure plummeted to a mere 6%. The metal alloy used to make the part turned out to be unreliable and prone to rapid fatigue under stress. Recognizing the severity of the situation, the military issued the engine manufacturers a harsh ultimatum. find an engineering solution as quickly as possible, and permanently fix this deadly problem. As it turned out, the attempt to extend the range of Soviet fighters to that 1,000-kilometer benchmark turned out to be a futile, even counterproductive idea. The extra fuel significantly increased aircraft weight, and their speed and maneuverability predictably suffered. This was exactly the problem that hit the developers of the MiG-3 and the WW2. Under the rigid Soviet command structure, designers had no choice but to follow orders from above without question. Dissent could carry severe personal consequences. Interestingly, the production Yak-1 was spared these experiments. Although government directives at the time required every single design bureau to increase the range of Soviet aircraft, the Yak-1 developers managed to avoid this. As a result, the aircraft kept its excellent flight characteristics intact. The one exception in Yakovlev's bureau was the experimental I-30 fighter. To achieve the required range, its fuel capacity was increased from about 670 to 850 pounds, but this aircraft never made it past the prototype stage. Meanwhile, in the spring of 1941, Soviet leadership issued a new order. Starting in August, the main aircraft factory was to produce 20 MiG-3 fighters per day. This pushed the total production target for these aircraft that year to nearly 4,500 units. But even during such massive assembly line production, engineers never stopped improving the MiG-3. They constantly introduced changes based on real flight tests and testing in a large wind tunnel. To make flight more stable and safer, in the spring, the designers decided to compromise and reduce the rear fuel tank capacity to 37 gallons. Testing in May of the updated production aircraft with heavy armament showed that its maximum range now stood at roughly 580 miles. Soviet military pilots noticed the improvement right away. They reported that with less fuel on board, controlling the aircraft during takeoff, steep maneuvers and landing became much easier. The aircraft got airborne faster and was significantly more stable in a climb. In steep turns, the MiG-3 also became more reliable, and the time to complete a turn was cut by several seconds, which in the heat of aerial combat was absolutely critical. By summer, production models began receiving automatic leading-edge slats. This upgrade made it far easier for pilots to recover from spins. In the second half of 1941, the fighters received yet another round of upgrades. They were fitted with an updated AM-35A engine with modified gearbox settings and a new propeller with a wider blade pitch range. The cockpit was finally protected with armored glass, and external drop tanks were added for long-range missions. To prevent the aircraft from exploding when hit by enemy fire, an inert gas system was introduced to fill the fuel tanks. Engineers also redesigned the tail assembly and ailerons for better control in the air. All of these upgrades not only improved the MiG-3's handling, but also significantly boosted pilots' chances of surviving combat. Responding to numerous complaints from frontline units about finicky engine cowl latches, the designers addressed this problem too. On one experimental aircraft, they tested a new, far more reliable fastening system. It was copied from the German Messerschmitt Bf-109 and was later successfully introduced into mass production. Engineers also tackled engine protection from debris. To prevent sand and dust from entering the air intakes during takeoff and landing, engineers installed special automatic shutters. These opened and closed in sync with the deployment or retraction of the landing gear. In August 1941, leading Soviet researchers proposed reshaping the wingtips of the MiG-3 to a trapezoidal form. In theory, this would have allowed for larger flaps and reduced the aircraft's landing speed by approximately 3 miles per hour. However, this concept had to be quickly abandoned. First, such a modification would have required significant retooling of production lines, which in the middle of a war was simply unacceptable and would have inevitably delayed deliveries of aircraft to the front. Second, that 3-mile-per-hour difference was so small that pilots might not even notice it. During serial production, the MiG-3's armament was constantly being refined. In early 1941, Soviet aircraft factories began rolling out these planes with 5 weapon stations right from the start. 2 heavy-caliber machine guns were additionally mounted under the wings, each carrying 145 rounds. However, due to a nationwide weapons shortage, these machine guns often had to be urgently redirected to other factories. The additional firepower made the aircraft considerably heavier, which seriously hurt its speed and maneuverability. Because of these problems, production of this heavily armed MiG-3 variant had to be limited to a batch of 821 aircraft. What's more, the extra wing-mounted machine guns were eventually removed from all fighters of this series that had already been built. To make the MiG-3 more effective in actual combat, in the summer of 1941, leadership ordered a change to its standard armament. Engineers searched for the ideal balance, testing several machine gun configurations. Eventually, in the fall of that same year, a lighter version with just 2 machine guns went into mass production. But thanks to removing the extra barrels, the ammunition supply was more than doubled, from 300 to 700 rounds. Before the factories had to be evacuated ahead of the enemy advance, Soviet workers assembled over 300 of these aircraft. A significant number of them were also equipped with special launch rails that allowed pilots to fire powerful RS-82 rockets. Since late 1940, Soviet designers had been exploring ways to mount 2 full-sized cannons on the MiG-1 and MiG-3 fighters, synchronized to fire through the propeller arc. Specialists analyzed all available aircraft cannons in 20mm and 23mm calibers. After lengthy deliberation, they went with the proven Schwach system, since industry was already well equipped to manufacture it in large volumes. However, the German invasion and the subsequent forced evacuation of factories to the east derailed these ambitious plans. So in 1941, significantly boosting the fighters' firepower simply was not in the cards. In the summer of 1941, to protect key factories from enemy bombing raids, a decision was made to set up additional assembly lines deep in the rear. And by fall, when the situation on the approaches to Moscow became truly critical, a massive evacuation began. Entire factories, along with heavy equipment and thousands of workers, were loaded onto trains and shipped deep into the country's interior. A monumental but often grueling operation carried out under wartime pressure. The main MiG-3 production facility was also relocated to the safer city of Kuibyshev, where they planned to resume production of these combat aircraft as quickly as possible. But by that point, the realities of the front dictated entirely different priorities. Soviet aviation already had 3 types of fighters in service, while armored ground attack aircraft were in desperately short supply along the defensive lines. The MiG-3 was constantly plagued by technical problems caused by the troubled AM-35A engine. The deciding factor was that these engines were built at the very same factory that produced AM-38 engines for the IL-2 ground attack aircraft. The choice was obvious, and fighter production had to be permanently discontinued. In late December 1941, following a direct telegram from Joseph Stalin, MiG-3 production was completely halted, and all available capacity was redirected to building IL-2s. During the difficult evacuation period, only 22 fighters were completed, though they were already armed with those long-desired Shivyak cannons. In the spring of 1942, when the Design Bureau returned from evacuation back to Moscow, work at the new experimental factory was led by chief designer Artem Mikoyan. From parts, assemblies, and finished components that had survived the evacuation and been brought back, workers assembled a final batch of 30 MiG-3 aircraft. Most of these planes were subsequently handed over to the Air Force, while a few more went to naval aviation. All of these last fighters also received the long-awaited powerful armament, 2 synchronized Shveki cannons each. The installation of these weapons had been previously worked out and successfully tested on 1 experimental aircraft. In addition, 2 older fighters that had specifically arrived at the base for major overhaul were also retrofitted with the new powerful cannons. Between 1940 and 1942, Soviet industry produced over 3,422 to be exact, MiG-3 fighters. These aircraft featured a well-thought-out design and an extraordinarily high level of parts commonality. Thanks to this, even after serial production completely stopped, the planes continued serving for a very long time. Maintenance crews in the Soviet Air Force and Navy proved highly resourceful. Mechanics managed to assemble 1 fully combat-ready fighter from 2 or 3 heavily damaged ones. The last MiG-3s were only retired, completely worn out, at the very tail end of World War II. Around mid-1941, designers developed a special mounting bracket for installing an AFA-1 camera on the MiG-3 fighter. Military leadership ordered immediate action. That same day, engineers were to prepare the first photo reconnaissance aircraft and within a few days, 3 more. Initially, 4 production fighters were fitted with the special equipment and immediately sent to military units for real-world testing in the skies. Soviet pilots evaluated the new systems and reported back with their findings. Engineers listened to their recommendations, made the necessary changes to the blueprints, and created a 5th, improved reconnaissance variant. It was this updated version that successfully passed all state evaluations and received the green light from command. In 1943, Soviet researchers decided to strip down 2 MiG-3 fighters as an experiment. The main goal was to push the aircraft to reach significantly greater altitudes. One of these fighters was stripped down to the bare minimum. By removing everything non-essential, its flight weight decreased by about 400 pounds to roughly 6,830 pounds. This risky move paid off. The maximum flight altitude or service ceiling for this particular MiG-3 rose to an impressive 38,550 feet. In the fall of 1940, military engineer Frantsev sent the aircraft factory's leadership a list of new and demanding requirements for upgrading combat aircraft. These specifically addressed fixing known defects in the I-153 and I-200 planes. One of the top priorities was to design and install a fully pressurized cockpit on the I-200 fighter and then submit it for rigorous state testing. Beyond that, military leadership demanded the production of a small series of 10 I-153 aircraft, also equipped with pressurized cockpits to protect pilots at extreme altitudes. The design of the pressurized cockpit for the MiG-3 was assigned to chief designer Alexei Shcherbakov. Over the course of 1941, his team developed 3 different variants of such a cockpit. It seemed like a solution had been found, but reality got in the way. The overwhelming strain on the aviation industry, the outbreak of war, and the urgent evacuation of factories effectively killed the project. At the very start of the war, Soviet naval aviation pulled off an unusual tactic: the use of a so-called composite dive bomber. This was a unique system where a massive TB-3 carrier aircraft hauled 2 light I-16 fighters, each loaded with FAB-250 bombs. Building on this limited operational experience, military commanders asked designers to create a similar airborne system, but using more modern hardware. The idea was to suspend 2 MiG-3 fighters beneath the massive wings of the heavy TB-7 bomber, also known as the P-8. Each of these fighters would carry 2 FAB-250 bombs. Engineers ran preliminary calculations and concluded that the dimensions and payload capacity of the TB-7 did indeed allow for mounting 2 MiG-3s under its wings along with their bomb loads. All that was needed was to install special mounting beams for the fighters and slightly reinforce the internal structural elements of the carrier aircraft's wing. It sounded like a perfectly feasible task. However, this impressive project never made it off the drawing board. The aircraft factory was so overloaded with other more pressing frontline orders that management simply refused to spend resources on such a complex conversion. Although the project was canceled, the archives preserved the projected specifications of this combined system. The maximum takeoff weight was to reach nearly 73,850 pounds. If the system flew at an average weight of about 66,000 pounds with all 6 engines, 4 on the bomber and 1 on each MiG-3, running at full power, the speed could have reached roughly 250 to 260 miles per hour. The exact figure depended on which engines the P-8 carrier was running, M40 or AM-35A. The maximum flight altitude was estimated at roughly 29,000 feet, assuming the fighters drew fuel from the bomber's tanks while cruising between 16,000 and 20,000 feet. The range could have been 820 to 900 miles. The entire flight from takeoff to landing would have lasted 4.5 to 5 hours. In 1941, Soviet aviation designer Alexander Senkov proposed an unusual project for the MiG-3 fighter. His idea was to equip the aircraft with an additional wing that would function something like a sail. According to the designer's concept, it would deploy just before landing. The main goal of this innovation was to significantly reduce the aircraft's landing speed, which in theory would have made things easier for pilots and made touchdowns safer. However, Soviet aerodynamics experts quickly shot down these hopes. According to their findings, the additional canvas wing essentially turned the high-speed MiG-3 into a crude biplane, wrecking its monoplane performance. On top of that, the mechanism added over 550 pounds of extra weight. With that kind of addition, there was no way landing speed would actually decrease. On the contrary, controlling the fighter during landing would have become even harder. But the most critical flaw was something else entirely. Once deployed, the sail wing couldn't be retracted. If an emergency situation arose and the pilot needed to urgently go around for a second approach, the deployed sail would have caused serious problems and could easily have led to a crash. Considering all these obvious risks, the Commission rejected the proposal and the project was permanently shelved.